Hello everyone. Now that we've learned the derivative rules, especially for polynomial and rational functions, we're going to talk about word problems, okay, specifically rate of change problems. So as the name implies, right, these are situations where you're looking for the rate of change, right? You have some kind of a function and you're being asked to find something to do with its rate of change. Okay, that most likely means that you're going to want to take its derivative and then use the derivative to find out whatever information you want to know about rate of change. Okay, so for example, in the note on second derivatives, we've already talked about position and speed, right? If you have a position function, then the derivative gives you information about the speed of the object, okay, which is the rate of change in the position over time. If you had something like a population function, right, its derivative would give you information about the rate of change at which the population is changing, right? The population function would tell you, how many people there are, but the derivative would tell you something like, the population is increasing by 1,000 people per year or decreasing by 2,500 people per year, right? Something like that. So the original function gives you, the quantity, and the derivative gives you the information about the rate of change. So just in general, if you were given a function that asks for rate of change, most likely you need to take the derivative and then do something with the derivative. Okay, the specific type we're going to go into a little bit more detail with in this note is business application type functions. So this page is just a bunch of definitions. So the demand function, okay, or it could be called the price function, but they call it demand. If you've heard of the whole supply and demand thing, right? That if you have more stuff on the market, the price would have to go down, and so on. That's kind of what this function is supposed to model, right? I can put in how many things I want to sell, and it will tell me the price at which I can sell those items. Okay. So that means my revenue function, right, the amount of money I take in, is x times p of x. Okay, so again, x here is representing how many items are being sold, right? So it's the number I sell multiplied by the price that I can sell them at. So, right, number sold times price gives you the total revenue of selling all those items. Okay, you could have an associated cost function, right? How much does it cost to produce so many items? Okay, and finally the profit function, right? How much money you make is simply the revenue function subtract the cost function, right? If I figure out how much money I take in, subtract my costs, that is your profit. Okay, in terms of rate of change, we have some specific names for these things. Okay, but we'll start with cost. So the marginal cost, right, which is C prime of x, is the approximate cost of producing one more unit, right? How much is it costing per unit to make it at that level, right, roughly. Same idea with marginal revenue. Okay, it's about how much more money you're going to make by selling one more item. Okay, and marginal profit is the approximate profit from selling one more item. Okay, how much more or less will you make if you ramp up and sell more items? Okay, so we're just going to go through one example that kind of shows how to set up a number of these functions. I know in some of the problems in the textbook, they just give you the functions and you just have to work with them, but sometimes you'll need to develop the function from scratch. Okay, so here's an example. Okay, after realizing the multiply app might be a bust, Mr. Kemp and Mr. Barsawa decided to author a math textbook instead. Okay, they estimate that if they set the price of the textbook at $100, they'll be able to sell 500 copies. For every $2 the price drops, they can sell another 40 copies, and it costs $50 to produce each book. Okay, so before I get into the details of what we're going to do here, okay, you might remember doing a problem like this, maybe say in the grade 10 course. Okay, what you would usually do here, because it's telling me about how I'm changing the price, you'd have something like, let n be the number of price increases or decreases. Okay, in this case, let's say it was drops, so decreases. Okay, and you'd set something up like this, right? It says the current price is $100, and I'm going to drop the price by 2. Okay, and when I do that, that means the number of copies I sell goes up by 40. Okay, and then my total revenue would be equal to this. Okay, right? It's because this part is basically my price, and this is how many I sold. Okay. The difference here is that I'm not modeling the number of times I'm changing the price. Okay, all of these functions are in terms of how many items I am selling. Okay, not the number of times I change the price. Okay, so the setup is going to be, it's still going to use this information, but we're going to use it a little bit differently in setting up this function. Okay. So the first thing we're going to do is determine the demand function, right, which is my price. What's the price I can set? Well, so X is units sold. And we'll still use that N is number of price changes. Okay, because we're still going to use the same technique we were just looking at to set this up. So I know, right, for my price, okay, what we talked about there is still true, okay, that it's currently $100, and it's going to go down $2 every time I change the price. But I would like this to be in terms of the number of units sold. Okay, but that was the other part we figured out. Okay, the number of units sold is equal to 500. Sorry, that's not N. Okay, the number of units we sell, right, X is equal to 500 plus 40 N, right? Every time I decrease the price by $2, I get 40 more customers. So in order to create P of X, I'm just going to rearrange this to solve it for N, and then pop it back into this expression here, and we're pretty much good. Okay, so bring over 500. Divide both of those by 40. So I have X over 40 minus, okay, minus 12.5 is equal to N. Okay. So now that I have, right, my price changes in terms of the number of units, okay, I go back to my P of X equals 100 minus X over 40 minus 12.5. Okay, and we'll just do some tidying up there. Okay, so wait, I feel like I missed something there. Yes, it's a 2 in front of that expression. Okay, so negative 2 times negative 12.5 is positive 25. So I'm going to have 125 minus X over 20. Okay, so there's my demand function in terms of the number of items I'm going to sell. Okay, so now we're going to create a profit function. Okay, so that is going to be, so P of X is equal to the revenue function, R of X, minus the cost function. Okay, so the revenue function from the definition is X times P of X. And I'll leave cost alone for a second. Okay, so we have X times, okay, the demand function we just created, which hopefully will appear here. Pretty close. Okay, so 125 minus X over 20. Okay, so that means it's 125X minus X squared over 20. So what about the cost function? Well, we'll go back to our original information. Okay, it said it costs $50 to produce each book. Okay, so that means that our cost function would just be 50 times x. Minus x, so minus 50x, right? That's $50 per book. Okay, so tidying that up, I'm going to have 75x minus x squared over 20. And there's my profit function. Okay, determine the marginal profit function. Well, there's our profit function that we just had. So the marginal profit is basically just the derivative there. So now I need to figure out what is p prime x. Okay, and we have lots of experience with this now. So derivative of 75x is just 75. Okay, so derivative of x squared over 20, well, the 2 would come down in front. Okay, over 20 is really just a constant, so I don't have to worry about quotient rule here. And maybe I'll show that on the side for a second. But the 2 would come down, so I'd have 2x over 20, but that would reduce to x over 10. Okay. If that wasn't totally clear, I'll just talk about this on the side for a second. Right, this is the derivative of x squared over 20. Now, x squared over 20 is the same as saying 1 over 20 times x squared, right? So the denominator is really just a constant. So I don't have to use the quotient rule there. So I just simply bring down the 2. I have 2 over 20x, that reduces to 1/10. Okay, so that's where I ended up with the x over 10. Okay, so that's what my marginal profit function looks like. Okay, last thing. What price should be set to optimize the profit? Okay. So I'm going to bring both my functions over here just to talk about briefly. Okay. But to optimize profit, I want to make the most possible money. Okay. My original function, p of x, okay, this is quadratic. Okay. And it's got a negative in front of the squared part, right? So it's kind of your classic parabola that looks like that. So the optimal profit will occur at the vertex. Okay. Well, how can I find the vertex? Well, I could do some quadratic work here. Okay, or I could note that basically at the maximum possible profit, it means the marginal profit is going to be 0. Okay, I'm not going to make any more money by selling more items. In fact, I start going to lose money because the costs are catching up with me. Okay, so a slightly quicker way to do this is to take my derivative and set that equal to 0. Because my maximum profit will occur at that peak. Okay, so now I just solve this for x. So that means x over 10 equals 75. And so x is equal to 750. Okay, so the number of items sold would be 750. That's where the maximum profit occurs. Okay, but the question asks us for the price. Okay, so now I'm going to go to my demand function, p of x, which was 125 minus x over 20. Okay, now I know how many items I'm going to sell. So I plug in 750. End up with $87.50. Okay, so the best possible price to sell the book at to make the most money is $87.50. So yeah, I was just laying out the business just because there's all of those functions and just knowing which one is which. Okay, so in the practice work, okay, there are a number of questions that do involve business. Okay, but there are some questions that don't. They just have other functions. Okay, but they'll just give you the function. And again, if it asks you for rate of change, then most likely, right, you just take the derivative of the function and then figure out what it needs you to with rate of change. Okay, thanks for watching. And as always, if you have questions, please send me a message.